In this one, we're doing a few more assorted proof problems for A-level maths. Let's go. First up then, we want to complete this table for 3 statements. So, first up, when a real value of x is subbed into x squared minus 6x add 10, the result is positive. Alright, so to test that for a quadratic, we need to write it in completed square form. So x squared minus 6x add 10 can be written as x minus 3 squared and then subtract 9 on the outside, so we get plus 1. So that tells us the minimum value is 1. And 1 is greater than 0, therefore x squared minus 6x add 10 is indeed always greater than 0. So that's always true. But 2, if ax is greater than b, then x is greater than b over a. Alright, so we need to think about 2 cases there, a positive and a negative. So if a is greater than 0, then, or if a is greater than 0 and ax is greater than b, and then x is indeed greater than b over a. Now, if a is negative, so less than 0, and ax is greater than b, now when we divide inequalities through by a negative number, the sign flips direction. So x would now be less than b over a. So this one is only sometimes true. Alright, then number 3, the difference between consecutive square numbers is odd. Alright, so we need to define these consecutive square numbers. So let's say let n be an integer. And then n and n add 1 are consecutive numbers. So we then want the difference between their squares. So n add 1 squared minus n squared. Now that is going to give us n squared add 2n add 1 minus n squared. And that leaves us with 2n add 1. Now, 2n is even, and then an even add 1 is an odd. So, therefore, it's odd. So, this one is always true. Number 2. A student notices that when he adds two consecutive odd numbers, the result always seems to be the difference between two squares. He attempts to prove this. So, all he's doing is chucking some numbers into the rule. Now, part A asks us to explain what's wrong with his proof. So, the problem is it doesn't test every case. You can never prove something like this just by testing a few cases. So, the problem is his method is not exhaustive. Alright, and then part B wants us to prove his claim is correct. So, we are going to do what he should have done. So, we need to define two consecutive odd numbers. So again, let's say let n be an integer. So then, two consecutive odds would be 2n add 1 and 2n add 3. So, 2n add 1 and 2n add 3 are consecutive odds. Alright, so then 2n add 1 add 2n add 3 is 4n add 4. Alright, so that doesn't really look very useful, except it's the tail end of a quadratic. So 4n add 4 is actually n add 2 squared minus n squared, which then is a square minus a square. Next up, prove that for all n in the natural numbers, so that's positive integers, n squared add 2 is not divisible by 4. Alright, so we need to test them all without testing them all. So the way we're going to do this is by categorizing numbers into odd and even. So let's say let x be a positive integer and we're going to test n being odd and even. So when n is odd, we can say that n is 2x add 1. So then let n be 2x add 1. So then n squared add 2 is 2x add 1 squared add 2. Alright, so that is 4x squared add 4x add 3. So we can say this is odd, therefore not divisible by 4. Alright, now we need to check n even. So when n is even, we can say let n be 2x. So then n squared add 2 is 4x squared add 2. Now that is a multiple of 4 add 2. So we can say this is 2 more than a multiple of 4. Therefore not divisible by 4. Alright, so we've checked every case. So we then just need to finish by saying therefore n squared add 2 is not divisible by 4. Okay then, part 2. Given that x is in the reals, the value of the modulus 3x minus 28 is always greater than or equal to x minus 9. State, giving a reason, whether this is always, sometimes, or never true. So, the way that I'm going to do it is using a graph. So, y is equal to x minus 9 is or looks like this guy. So, something like that. Alright, now it crosses the x-axis when y is 0, so x is 9. Alright, then we need to think about the modulus of 3x minus 28. So, let's just think about the normal part of the graph. So, we're going to find where it hits the x-axis. So, 3x minus 28 is equal to 0 tells us that x is 28 over 3. Now that is just bigger than 9. So that tells us the graph is going to look something like this, where the x-intercept is 28 thirds. And from that, we can now see there are some points where the modulus is less than x minus 9. So the statement is only sometimes true. Alright then guys, that's the end of that one. Next up, proof by contradiction. Hope to see you there. Take it easy. Take care.